We want to talk today about polar coordinates. Normally, in Trig, we of course deal with the x and y axis, and even in Trig, we oftentimes will say if I want to plot the point 4, 3, I go 4 on the x-axis and 3 on the y-axis. And there's my point 4, 3. Polar coordinates is a different way to describe this point here. So we sort of call this the XY coordinates, the XY coordinate system. But I'm going to take this same point here, and instead of describing it, giving the value of x and the value of y, instead I'm going to give two pieces of information, but they're not going to be x and y. So in other words, this is like x and y. Instead, the two pieces of information inside the parentheses are r and theta. So let's talk about what r and theta means. In terms of graphing, we could think of r as the distance from the origin of the graph, and theta is the angle from the x-axis. All right, that may not be totally clear now. Let me go ahead and give you a couple of points written in polar coordinates, and then we will go graph them. So for instance, I could have the point, I'll call point P 2 pi over 4. So I'm going to go plot this, and just so you know, when you're plotting points with polar coordinates, you always want to start with the angle. And I'll show you what that means in a minute. So here, we could still, it's not incorrect to still call this xy, but we're not really going to use xy points to graph this point. I'm going to use polar coordinates. So r is like the distance or the length from the origin to the point, and this is like my angle. So starting with the angle first means go to the angle of pi over 4. Okay, we're assuming that the x-axis, like always, is like the starting point for angles. And we know pi over 4, if we think back to thinking of the unit circle and stuff, pi over 4 is halfway between the x-axis and the y-axis. So it's almost like I could draw a dashed line for pi over 4. And now, once I know my angle, I go a distance of 2. And let's just assume maybe that's a distance of 2. Maybe my, here's a typical coordinate system. That's a distance of 2. So in other words, the angle is pi over 4. The distance is 2. So therefore, in polar coordinates, we call that point 2 pi over 4. What if I want to graph another point, and maybe I would call it 7 pi over 6. So you go find the angle first. 7 pi over 6 is, this time I'm not going to draw on the dashed line, but it's right about here. And if I go a distance of 1, maybe it's right here. And a lot of times what you do with polar coordinates, even though it's not a vector, sometimes it's like we'll draw a line. It's not a very good line. We'll draw a line here to indicate the distance. So that point represents 7 pi over 6. So really not too difficult, especially since we have a pretty good feel for measuring angles on this coordinate system. It's sort of just like unit circle kind of stuff, those angles. However, there are a couple twists that can happen with polar coordinates. Both these points I've gone over so far have both positive r and positive theta, but it doesn't have to be that way. For instance, how about I want to plot the point -3 pi over 2, where that is in polar coordinates. So first thing I'll do, I'll go ahead and find my direction. Of course, pi over 2 is straight up. It's like the y-axis. And now my distance, or my length, is -3. Okay, what's the impact of when the length is negative? Well, what that means is 3 pi over 2 would be up here, but the -3 tells you basically you have to go in the opposite direction. So if +3 is up, so this is pi over 2, this is 3 pi over 2. Positive distance, positive angle. However, the negative distance causes you to basically just go in the opposite direction. So in other words, now I'm going to go right here. Just for fun, comparison's sake, that would be 3 pi over 2, and here's -3 pi over 2. So the negative number causes you to go in the exact opposite direction. We also can have negative angles. How about, let's try and plot the point 2. How about -pi over 6. Okay, so if you start with our angle, but this isn't too hard because previously we used to have sometimes some negative angles, and negative angles just means you go in a clockwise direction. So negative pi over 6 is sort of in here somewhere. And a distance of 2, so maybe I would go, who knows, right here. If I want to draw a line. Looks like a vector, but it's not. It's just a way to indicate this point here. And that point there is 2 negative pi over 6. So this is a distance of 2, a length of 2, and the angle is negative pi over 6. Just for fun, let's do one more. What would we have if we did -1, -5 pi over 4. So as always, go to the angle first. So -5 pi over 4 means we go in the negative direction. -5 pi over 4 is up here. Of course, being -1 means now I have to go in the opposite direction. So if -5 pi over 4 is here, the -1 causes it to maybe be like right there. And that would be -1, -5 pi over 4. All right, so that gives you an idea of how to plot these polar coordinates. You have your distance or your length, which can be either positive or negative, and then you have your angle, which also could be positive or negative. And you notice most of the time now in polar coordinates, they like to put the angle in radians. So now we're back to radians. Now here's another interesting thing when you start working with polar coordinates. Just as a basis of comparison, when I plot a point in the old traditional XY coordinate system, if I go plot the point 1, 4, there is only, when I say this point here, this point is 1, 4 and only 1, 4. There's only one XY coordinate that describes this point. But let's think about, on the same graph, what if I were to plot the point 2 pi over 4, just to keep it easy. So this is in polar coordinates. So I go to pi over 4, which is sort of like a 45-degree angle, distance of 2, so I don't know. I'm not looking at 2 here. Maybe distance of 2 is so that point right there is given by 2 pi over 4. But just for fun, how about I go plot the point 2 9 pi over 4. Now this is where you've got to remember sort of like the unit circle. We know in terms of radians, one trip all the way around the circle is 2 pi. I need to find this angle, and hopefully you can look at this and realize that this angle is actually larger than 2 pi. Matter of fact, if I try and break it up, I can say 8 pi over 4 plus pi over 4. That equals 9 pi over 4. Of course, 8 pi over 4 is 2 pi. So what does this tell me about my angle? My angle is 2 pi's one trip around, and then I go pi over 4 more. So here's my angle. Actually, it's the same angle as 2 pi over 4. And since my distance is 2, you know what? I end up at the same point. It's almost like there are now 2 ways to describe the same point. I can say that point is 2 pi over 4, and I can say the point is also 9 pi over 4. Just for fun, how about if we go plot the point -2, (5 pi over 4). Let's go plot that point on this same graph. So 5 pi over 4 is actually over here. What's my distance? It's -2, which means the length is 2, but I have to go in the opposite direction. And you know what happens? I end up at that same point. So now actually I've got 3 different polar coordinates for the same point. And that's one interesting thing about polar coordinates. When you have a point on your graph, there are many different ways, many different polar coordinates for that one point. That's not true when we talk about x and y coordinates. This point is x equals 1, y equals 4, and that's it. There's no other xy coordinates that give me that point. However, if I look down here, this point here, in polar coordinates, 2 pi over 4 is this point, 9 pi over 4 is this point, -2, 5 pi over 4 is this point. If I want to take the time, I could come up with even more. So it's just interesting how with polar coordinates you can have one point have different polar coordinates. As a matter of fact, let me finish up this video by doing a problem that's pretty common, where they give you a polar coordinate to start with, and then they give you a list of other polar coordinates, and they ask you which points on that list actually are the same as the original starting point. So for example, here's the original starting point. 4 (-pi over 2). Matter of fact, easiest thing is just to sort of plot this, and then as they give me all the other choices, I can see if they line up. So let's plot 4 (-pi over 2). So (-pi over 2 means I move in the clockwise direction, and we'll say, so right there. Now here's what they do. They give me 6 more points, and they say of these 6 points in polar coordinates, which ones represent the same point. So all you do is you simply, here's the first point. I'm going to write the point down, and since I'm going to go graph it and see if I end up at the same point. So 4, 5 pi over 2. 5 pi over 2, I got to think about that. That's 4 pi over 2 plus pi over 2. So really, what this point is really is 2 pi plus pi over 2. So one trip around the unit circle, and then pi over 2. So right now I'm on the positive x-axis, and actually that point would end up here. So I can say, nope, that is not the same point as 4, negative pi over 2. They give me another point. 4, 7 pi over 2. Let's figure out the angle. Once again, it looks like this is going to be bigger than 2 pi, so I need to sort of, in a sense, subtract out or reduce down, get rid of all the 2 pi's. So in this case, I would say 7 pi over 2 is 4 pi over 2 plus 3 pi over 2. And of course, this is 2 pi. So really, my angle is going to be, in a sense, 3 pi over 2, because 2 pi just takes me around the circle. So let's go to 3 pi over 2, which is my negative y-axis, and now a length of 4. And you know what? I'm at the same point. So 4, 7 pi over 2 is the same point as 4, negative pi over 2. And what's the third one? Let's go find out where negative 4, negative pi over 2. Now we should be getting better at these. So negative pi over 2 is the negative x-axis, but negative 4 puts it up here. That's not the same point. How about 4? Let me go over here. 4, negative 5 pi over 2. Negative 5 pi over 2 is one trip around the unit circle. That's negative 2 pi, and then negative pi over 2 more. So really, when I plot this, I'm really plotting negative pi over 2, which is my negative y-axis, and a distance of 4. Turns out I'm at the same point. And now a couple more. How about negative 4, negative 3 pi over 2. So let's go find the direction. Negative 3 pi over 2 means in the negative, sort of clockwise direction, go to 3 pi over 2, which is sort of the positive y-axis. But now my distance, or my length, or the r, is negative 4, which causes me to go in the opposite direction. So lo and behold, I actually end up at that point. So negative 4, negative 3 pi over 2 is the same point as 4, negative pi over 2. And the last one is negative 4 pi over 2. So let's go to my pi over 2 angle, which is right here. Negative 4 causes me to go opposite direction, down 4. I'm at that point. So of these 6 points they've given me, 4 of them actually are the same point. 2 of them are not. All right, so that's the introduction to polar coordinates.